So welcome everybody. This is office hours. Our FPGA meetup at Open Research Institute. And what we do is we talk about what we have done and any roadblocks that we are facing. And so usually we do a round table for that. So I think we'll start with Aaron and yeah, just share what you've been up to. Please, Aaron, you have the floor.
Hi, Happy New Year, everyone. So what I've been working on lately is more updating my lab. I've been running 1804, Ubuntu 1804 for the longest time and on my main machine. When I finally updated it to 2204, I was having trouble building the Opulent Voice C code because of my compilers were too old. But now I shouldn't have that problem anymore. I've been working on a board support package in OpenCPI. We call them OpenCPI support projects for the ZC706, because I know that's one of the boards you have in the lab. And once I get that going, which I'm almost done with, I'll start looking at, I personally have access to a 809371 that I want to get the JESD 204 interface working within OpenCPI so that we can have a receiver on a beefier FPGA. And hopefully that work can translate over to the 80RV 9009. At least that's my hope. Most of it uses the same interface. As far as Opulent Voice, I've been able to get the C implementation that I have running with. It's still not perfect, and it should be perfect, but I've got the bit error rate down to about 0.01, so less than 1%. I'm still trying to debug and figure out what is causing that. And I'm running it. So I don't think it's related to the algorithm itself, and I think it's more an OpenCPI-ism that's causing samples to be dropped on the ADC. So I'll be seeing if I can improve that to get it to where it should be, which is a 0-bit error rate when it's in loopback. I did start updating my HDL repository with the latest and greatest of the Opulent Voice, the MSK implementation, but I haven't gotten far enough so I can test that. And another reason I wanted to update my OS is because the GTK wave was a pain to install in 1804. So I'm hoping that might be simpler so I can run the same simulations that Matthew has created. So that's what I've been working on. And I did get over the break bit by the CW bug in ham radio. So one of my New Year's resolutions is to become proficient enough to get on the air with that. That's it for me.
Wow, outstanding. That's an awful lot. Yeah, the GTK wave challenge, I think we're running into that too. So we also have some fairly elderly Ubuntu installations in remote lab, and we've talked a couple of times about whether or not to go ahead and update and upgrade them, which is a complicated sort of decision. So maybe Paul can comment on that, where what our current thinking is.
Maybe I can. We can upgrade on an experimental basis, very little impact, because we could spin up another virtual machine. In fact, we have virtual machines running on the more recent versions of Ubuntu for various purposes already. We're just not trying to do our main development on them. Anything we think might be suspicious on the new system, we could try on one of the VMs that does have the new system on it. They share the tools directories, so it should be fairly straightforward to check it out and see.
Yeah, there's a variety of OSs, and some of them let us do some things and others prevent it. So we basically, I guess the main point is that we share I think the same sort of landscape with Aaron. It's, eventually you have to make a call and you have to go ahead and upgrade your OS. And for a while, the versions of Vivado that we really wanted to use had a limit on how far ahead you could go on Ubuntu. But I think that's less of a problem today than it
Well,
was a year ago.
that's one of the reasons why I moved to 2204 and not 2404, because the Vivado tools still don't support that latest version of Ubuntu. So I'm not at the latest and greatest, but
Yeah,
I'm newer than 18.
right. Yeah, you got to pick the right one, and it's a balance, and
Yeah.
sometimes it'll surprise you. Like we we had an interesting challenge in the lab. We have a VM set up for MATLAB because Simulink requires a patch for glibc, and this may this things have progressed. Like this patch may no longer be required if we went ahead and updated to a more recent version of Ubuntu. But for that particular reason, in order to be able to run Simulink and MATLAB, all of the versions that we wanted in order to run them, then we had to do this patch from MATLAB. But that caused problems with other compilers. So we had to go to a different VM to cross compile for things like Petalinux for this ZC706 and the ZCU board. So we've been
Mhm.
doing like little dances and, evasive action and, secure copies across different things. And so we ever so often we need to take stock and like try to reduce the complexity and go back and if there's something that can be smoothed out, and now
Yeah.
is a good time to do that. So
If
Yeah,
I
for
can,
oh, go
um,
ahead, Matthew.
oh yeah, I wanted to. We do have a GTK up and running on the VMs. I think it's running on Choco Cat. And then Paul had spun up another VM for the NVC VHDL simulator. Um, so we do have a complete environment between the two VMs. I think GTK is working on Choco Cat if I remember right. But then we did have to spin up a new one for NVC since it needed a newer version of the operating system.
okay, that's probably what I'm thinking of. When he said GTK, I thought that was the one that we had to. But yeah, you're right. Thank you for the correction. Yeah, never a dull moment with computing. That's for sure.
Yeah, that's so for the ZC706, I am targeting the Petalinux version 2024.1.
Yeah.
So yeah, so the implementation of the SD card will be able to run at least on the 2204, Ubuntu
Uh,
2204.
In terms of Petalinux, have you heard anything about the current advice to go with more of a Yocto implementation, like Xilinx community or now AMD, I suppose is correct to say, but AMD kind of communicating that they would like for you to back away a little bit from Petalinux and to do straight up like Yocto. Have you heard this at all?
My understanding and digging into the builds is that it's already using Yocto underneath, and
Yes.
Petalinux is on top, the layer on top of that, that you can build simply with a couple commands. But I haven't heard otherwise of you're going to stop, I guess, developing Petalinux.
Oh, okay. That's a little more extreme than what I heard, but that's
Yeah,
sort of like
yeah,
that sounds like what they're trying to tell us without coming out and telling us that the Petalinux, there may not be any maintenance or any further updates, which would be kind of bad news if you want to keep using it
yeah,
for prototyping and all that. But yeah,
that
it's
is
it's
true.
Yocto under the hood, and I do have a set of build notes from Phil Ballister. So he's very involved with Yocto and very kind of interested and motivated to get it working for people. So one of the things on the list is to go to the lab and then attempt to do a build, for embedded Linux using his recipes, and to see because those recipes are in line with the sort of direction that people are being suggested to go in to rely more on Yocto rather than Petalinux and then report back. Um, but yeah, I don't anticipate it being too bad because like you said, we use Yocto under the hood anyway, so it shouldn't it
Mhm. Yeah,
shouldn't
yeah.
blow up or anything like that. And but yeah. So yeah, it sounds like you've heard you're filling in some of some of the missing pieces for me. And yeah, we'll just we'll look at that, and if we have to adjust to kind of dropping back to a lower levels, I'm in favor of that. Cool. Anything else, Aaron, that you'd like to share?
Nope. My update's done. Thank you.
Okay, well, cool. Thank you so much for all of this work. It's super interesting. And then I think I'll turn it over to Matthew because he has a lot to share and has been investigating a variety of things over the past couple of weeks.
All right, thank you. Sorry, no video since I'm traveling, but yeah, we over the break I implemented a IQ power measurement, or it doesn't, it's IQ or real, and it basically does a more or less root mean square, except there's no square in hardware, so we'd have to do that in software. But the base main part of that is a exponential moving average filter that's used to smooth the incoming data to do the mean. And yeah, at first I thought it was working, then I felt it was maybe not, but then I went through and optimized all the bit widths through, and now I think I'm getting pretty reasonable results out of it. I've posted screenshots and discussion on the Slack channel, so I'm pretty happy with that. So next steps will be integrating that into the modem, not into the demodulator, but into the top level, because it's kind of a separate standalone block. And so I think that's pretty good. It's implemented right now with DSPs slices, but I think if somebody wanted to kind of play around with the block and implement some shifters, I think that would be good. It would allow us to create more resolution because we're kind of limited in the DSP multipliers to a 25 by 18. But again, we're getting pretty good results. If I put in a sine wave into the say the I input, if I the output again is the square value, but if in the simulation I went ahead, and I can compute the square root and behaviorally, and then compute the dB, and we get a -3 dB value coming out of the power detector. So that's exactly what we would expect. So I think it's in pretty good shape. There's not much updates on the modem itself. I do have some new hardware coming, so I can try a Pluto to Pluto as well. I have a wild hair to try doing a software MSK and then transmit or receive via hack RF. So I'm not sure I'll get to that, but I think that would be useful. And then there's another hardware stick called the Yardstick 1. It's the same Great Scott Gadgets that did the hack RF, and it has a TI chip on it that has an MSK transceiver, and so that might be interesting, to just broaden the scope of what our MSK modem could do. Potentially being able to interoperate with that Yardstick 1 could be, it would be an interesting exercise. Maybe again, if there's somebody wanted to on-ramp, that's something somebody could take on if it was of interest. I don't think there's a practical application necessarily, but I think it's a good learning experience, and being able to get something in the lab and see it work with another piece of hardware, that can be pretty satisfying. And then beyond that, I'm just starting to do a survey of papers, mostly what's coming through on archive, just related to HDL, or not even just HDL, but EDA applications, in particular Verilog generation, code generation, but they even have some papers that are touching on analog design, and I think there's some even on like equivalence checking. So I think could be some interesting stuff there that we might want to start playing with and experimenting with, if there's something that's that's practical or can be made practical. Um, so I think that's about it. Any questions?
Just to clarify a little bit more about what you're speaking of when you say EDI, so this is design and automation for for writing, and executing, implementing HDL or hardware descriptive language, and possibly using AI or ML to assist. And
Yes.
this is a huge area of interest and activity and research. There's a number of people in our community that are really interested in this, and we have a big active project, a open source EDA project locally at UCSD called Open Road, and they've also looked at this, and I would be willing to bet that probably some of the papers out there are from them. And I know a few of the people over there, and I think they would be interested in like uh, having a get together, having a meetup about this, and kind of working through things that we might want to tackle. Um, I know that there's a couple of other big organizations and groups out there. Um, the Tiny Tape Out probably have some overlap with them. And yeah, I'm really excited about this. I think it's great. The small bit that we've done to try to use like AI ML or automated tooling has been through HDL Coder in MATLAB. So we have access to that particular toolbox, and we've learned some things. You cannot come in with a big monolithic design, a complex design, because it will produce something that will swamp your part. But if you are targeted and you do one small little bit, you do the sort of a modular, very modular approach. Do one thing, do it well, and then you send that module off to get implemented. So your Simulink model looks very simple, but the code it creates is pretty darn good and very human readable. So that we have some experience there. And then a little bit of experience with things like Amaranth, which is Python to HDL. It's not strictly speaking AI/ML, but it is a conversion program, so it's using sort of an expert system. So I'm really excited about that, and looking forward to hearing more about it. And looking at the papers that you find. You're essentially doing a literature search right now, and it's quite the field. So yeah, thank you very much for digging in.
Yeah.
And let's see, you talked a lot about the power measurement, and I just want to thank you for talking about that on Slack and kind of highlighting the different approaches to power measurement, because we do have a received signal strength indicator that we're using. It's available in libiio, and it gives us like a good idea that the receiver is actually on and that it's receiving power. But I'm very, very interested in we implement our own, because I think that we're measuring power at a different place than the RSSI indication from libiio.
Yeah,
And
typically the RSSI is going to be, at the front end of the front end, right? So you usually have a lot of gain blocks and AGCs and stuff happening. So you don't the RSSI, you'd have to compute what it is all the way to the modem by looking at all the gain blocks to see what they're configured as. So it's nice to use be able to measure it in the modem directly. It's not a dBm measurement, but you can compute dBm from that. You can actually reverse that and get your RSSI from this power measurement. But it's more dBFS. And one of the things that it's really useful for is if you're loading your ADC, your ADC might have a particular place you want to load it in terms of voltage into the ADC. Like in my work for a lot of years, we've loaded the ADC about 75%, or it depending on our modulation, we can compute the back off, and so then we actually use a PDM output and control the AGC from the modem directly, and that's kind of nice because then you're not relying on some external circuit to say, to set that power level in. You're the modem saying, hey, I want more, I want less directly. We're not there yet, but there's a lot of nice applications by having the power measurement in the modem itself.
exactly, yeah. Well, well described. Yeah, it's just like standing back. If you're trying to direct a airliner coming into the gate, it's almost like, okay, you have the air traffic control that can tell you how to get to the airport, but then you need to be able to have somebody to actually steer you to the gate, and that fine level of control and visibility is the difference in all these different power measurements. So, I mean, at first glance, if you're not familiar with this type of work, then it looks like, well, so what? RSSI is RSSI, but it really isn't. And being able to get past all these other blocks to look exactly at what you're dealing with in the circuit is super valuable. And at a my last question about the power measurement is that this sounds like a really good like general instrumentation block, and that it should be like in the modem module, pantheon. So is it something that is standalone enough to where it can be its own thing?
Yeah,
Um,
I think that I view this as its own thing. It's just a general IQ or real, power measurement block. It'll measure either, and it's just drop in standalone thing.
okay,
And
cool.
and even more so is the exponential moving average filter that's in it is also its own thing, and that could be dropped in anywhere you wanted, an EMA, as well. So. It's kind of a twofer.
Cool. Okay. Yeah, that makes a lot of sense. Yeah, thank you so much. This is a big step forward. Um, okay. Yeah. Or anything else, Matthew, that we've maybe that we
Mm, no, not that I can think of. I mean, I think there's a lot to come, but this is I feel like we've made some good progress here, and looking forward, to keep getting the modem stabilizing and hopefully get working between two Plutos. So still some challenges and some work to do, but I'm really excited about how far it's come.
Yeah, it certainly is. Let's see. I'll turn it over to Paul briefly if you have any report.
I don't really have much to say. I spent most of the holiday either traveling or messing with my own personal lab computer, bringing it up to modern standards. In the last few days, I've been knocked down with cold, so everything is working in the remote lab as far as I know.
Sorry about the cold. They come for us all. So yeah, the remote lab has worked really well. What I did over the past couple of weeks is work or rework an AI ML experiment for RTTY or radio teletype. And this is a receiver for radio teletype communications. Um, and to train a model that would demodulate, decode, um, the actual audio signal. So these are synthesized audio signals, a project from a college university project. So I found it was really pretty nice. This fellow generates the signals, the audio signals, in MATLAB and adds in noise. So you have a lot of control over the signal. And so that synthesized data was what I used to train the model, and it's at least as good as FLDigi. So that is a paper that I'm trying to work up, and then maybe the next thing might be CW. Like Aaron mentioned, he's going to tackle CW and trying to master it as a human. And I got to tell you, CW is deceptively simple. A lot of people think it's binary, but it's at least binary because you have a spaces and then a dash and a dit. And there's a lot to it when you start kind of digging in. This is why that there is essentially only like rudimentary automatic, CW receivers. But the sort of the next step after RTTY is to look at CW. So that's what I spent a lot of time doing. So I use the remote lab essentially just for the VMs and for MATLAB and for the machine learning packages. I'll give a presentation about the work in February, and hopefully I'll submit the paper to QEX to see if we can get them to publish a little bit more of our work. So that was the sort of the main technical thing, along with studying Bayesian detection in order to get better at iterative receivers, of which LDPC is a really good candidate and is usually done with iterative receiver techniques. And the end goal here is to come up with an iterative receiver for MSK. Um, And that's kind of a challenge, because we may already can get with the Hodgart and or Massey receivers, but using iterative receiver techniques is really quite it's good to look at. So this will be an excellent comparison. And so my end goal with kind of developing some skill in iterative receiver techniques is to give it a shot and to see if we can't have a receiver that does something kind of different. So it's been a good hard slog working through the math and finding good books, and it's getting there, coming into focus. Most all of the papers and books are very, very heavy on the theory and pretty light on the examples and use cases, except for the Keith Chugg book. And so thanks to Paul for pointing that one out. And working through the use cases for turbo codes is going to help a lot I think for MSK. So that's what I've been up to. And then I will turn it over to Ken, so he can bring us up to date with what he's got planned.
Hi there. Can you hear me?
Yes, we can hear you, Ken. Well, I have to drop off for another meeting, guys. I'll catch you guys next week. Good talking to you. And again, Happy New Year, and see you guys later.
Okay, thanks, Aaron. Well, Michelle seems to be disconnected from audio. Go ahead, Ken, and give your report.
Yeah, I don't have a whole lot to report. I'm trying to re-engage and been kind of busy at work. But I think some of the stuff that I've been learning at work will help projects as well. I think I've become a lot more proficient with Git lately. And there's a fair bit of overlap. I appreciate the training bed that ORI gave me. I've been able to put that to use at my work, and I appreciate having this as a place to consolidate and do a launch. And now I'm going to try and find a way to balance work and still make a contribution here. So for fresh year and fresh start, and I'll be just trying to make a contribution. I think the main thing right now is to document the work with the polyphase filter and try and get it in kind of a regressible state. And okay.
I don't have anything else. Anything else from Matthew? Away from the keyboard. All right. I guess that wraps up the meeting. Thank you all for showing up. We'll try to improve Michelle's audio situation before next week. And thank you all for all your contributions and participation. And we'll see what we can do over the next few weeks. I guess we're officially into the after hours. Anybody wants to chit chat? All we have left is you, Rick.
No, nothing special here. A lot of work going on with antenna characterization and things like that for the Deep Space Society. We're putting together some new frequencies for our 60-foot dish to detect new pulsars and magnetars, and we're also getting ready for the big push in the next couple of months for the Venus-Earth bounce attempt. We're going to start by putting a kilowatt at 1296 into the 60-foot dish and see if we can hear anything bounced off of Venus. That ought to be a lot of fun. And then as soon as that window is closed, in a few months, we'll go back to science experiments. So, and I'm just paying close attention to what you guys are doing, because I think it's just absolutely the most interesting project I've seen lately. I hope we actually can do some on-the-air tests soon.
Yeah, we're all looking forward to that moment. Do you expect to actually be able to hear anything off Venus, or is it just be a matter of detecting it in the?
Well, I probably shouldn't say too much, because I wrote the proposal that got the grant money to do the job, but I'm trying to maintain an arm's length on the implementation team at the moment. I had a meeting with one of our scientists yesterday, and we have serious doubts as to whether the initial attempt will work, but I think we will get it to work. But I personally don't think we'll get it to work on 1296. I think we're gonna have to go higher. That's just my feeling at the moment. And the problem with going higher in frequency, while we have some potential issues with the 60-foot dish, I don't think they're insurmountable. The biggest problem that we came up with is getting a kilowatt, and when I say a kilowatt, I mean absolute maximum power, 1500 watts key down, 100% duty cycle, at higher frequencies than 1296. It's one of those things where we might actually have to build it ourselves. So that would be interesting.
That could turn into a lengthy project all by itself.
Yeah, it could. It's surprising to me that high power is not available easily off the shelf at 5 and 10 gigahertz, but it's not.
Not at a reasonable price or not at all?
Not at all. If it was just the reasonable price issue, we might write another proposal to somebody with even more money to overcome that. But we haven't even found at any price that kind of power at frequencies between 2.4 and 10 gigahertz. There's 3 ham bands there. I'll take any one of them. And the whole idea is to narrow the beam width so that we more completely illuminate Venus, which is hard to do. It's pretty far away.
Yeah, I guess that's the point. All right.
Anyway, keeping busy as you are too, I see. That's very good.
Yeah, I'm just keeping vertical is good enough for me for the next day or two. So I'm going to sign off and catch you guys later.
Okay. Take care.